Sticky notes for Chapter 23. Chapter 23 covers mining and minerals, and the AP test does ask you to know a little bit about mining and minerals. Not a whole lot to sticky note in 23, but a few items that are important. So the first sticky note here is on page 645. You need to know that Africa has the most mineral reserves in the world. It may have not started out with the most mineral reserves, but we've mined out a lot of places where the reserves were easy to get to. For example, California, with gold mining, we're called the Golden State because of gold mining, but we don't do much gold mining anymore because the cheap and easy gold sitting at the top near the surface, the Earth's crust, has all been mined out over 100 years ago. And so the gold that's left is deep and very expensive, and the cost of getting it out is not recouped in the cost of what you get for the minerals. So we still have gold in California, but not a lot of mining of it because it's very deep and hard to access. So Africa is the place where a lot of mining companies are looking to extract minerals. So we use minerals in almost everything in our homes. We extract from ores. Make sure you know what the word smelting is and what an alloy is. I'm also going to add on here an ore as well. Metal and ore. So these are some vocab words to know from this page. Smelting is basically melting metal, and it reshapes the mixture into things that we want. Okay, so mining has a couple of terms you need to know. The tailings, here we go. The tailings are what is left over after a mineral has been extracted from the ore. And the tailings are actually pretty toxic in some mining. Gold mining uses cyanide, which is a poison, and this can leach into rivers and streams. Sulfuric acid is used in copper mining, and this can make streams and rivers acidic. And then slag is also leftover compounds from mining as well. And these two together, slag and tailings, are the most environmentally damaging part of mining. And so very often on an AP test you'll see a question like that. What's the most environmentally worst part of mining? And you need to know it's slag and tailings. Okay, make sure you know what a blood diamond is, and also, let me go ahead and do one edit here. Also know that gravel is the most commonly mined substance. In fact, we have gravel mines here surrounding us around Santa Clarita. There's kind of a big fight over a gravel mine up towards Acton. The city is fighting a gravel mine being put in there because of the air pollution from all the machines and all of the trucks that haul the gravel away. It's called the CMEX mine, and Congress and Buck McKeon have been fighting it along with our senators as well, our state senators. So they've been fighting it in Congress in Washington, D.C. And then again, know what blood diamond is. On page 649, make sure that you know what acid mine drainage is. Acid mine drainage is natural sulfur that's found in rock, and when you mine into the ground, miners sometimes expose this rock that has sulfur, and then when it rains it creates sulfuric acid. And so this is what creates acid mine drainage. The toxic liquid created from acid mine drainage is called leachate. Leachate is also a term you will learn when we study Chapter 22, Waste Management. Leachate is also a liquid toxin produced from landfills. And here's a picture here of acid mine drainage. Subsurface mining is probably what you think of mining, where miners go into a tunnel underground. It is the most dangerous, but it's the least environmentally harmful because you don't do a lot of landscape alteration on top. But it's also the most dangerous for the miners as well. Here is a picture of an open pit mine. Our closest open pit mine is about an hour and a half away in the desert up in Boron, where they mine for borax. You can actually go visit the mine. There's a visitor center with an overlook. It's interesting to go to. Make sure you know what open pit mining is, the definition of placer mining, the definition of mountaintop removal. Mountaintop removals is one of those mining situations that's in the news quite a lot. Basically, you remove the top of a mountain, just like it says in the term. And it's very difficult to do reclamation on mountaintop removal because how do you put back together a mountain? And so there's a lot of people trying to prevent the landscape from being altered from mountaintop removal. And while I've never seen it personally, I haven't traveled in eastern Kentucky or western West Virginia to the Appalachians where they're doing this. The pictures in the video that I see of this process are pretty heartbreaking ecologically, in my opinion. However, they do provide jobs for people, and there's a lot of poverty in the Appalachian Mountain. And so some people fight for it in their area because they need the jobs. So mountaintop removal, these are the problems with mountaintop removal. It causes biodiversity loss of forests with a lot of endemic species, a loss of nutrient cycling in ecosystems, flash floods due to the lack of tree roots and percolation into the ground. Water is polluted from toxins such as selenium, and the selenium can cause birth defects, increased cancer, heart disease for people downstream. And this is a list that would be good to know, especially to write for an FRQ on an AP test. Again, mountaintop removal is one of those things that have been in the news quite a lot in the past few years, and things like that tend to be on FRQs. So I'm not saying it is or isn't because I really have no idea. I can't predict that way, but in the next few years I would not be surprised if it is on an AP FRQ. So reclamation of a mine is when you restore the land to as much of an original condition as you possibly can and replant the area with native plants. So in some places this is difficult because of soil degradation. In a lot of places they take out the fertile topsoil and then they try and replant when they're done, but it's more different layers of soil, whether it's B or whether it's C or D layers of soil, and that's not topsoil, and so the plants have a difficult time because the soil is so degraded. The topsoil is gone in a lot of places, or it's polluted in a lot of places. It's just not good. Alright, mining also occurs in the ocean. And mining in the ocean is called dredging. And dredging is where basically you scoop the bottom of the ocean up. And then you take that soil, well it's not soil, that dirt that's found on the ocean floor, and you run it through a wash plant to extract any metal. And when you suck up the bottom of the ocean, you're going to harm or kill the benthic. Benthic means living on the bottom. So any sort of benthic organisms that live there will be killed or have to move. And scientists and, geologists and mining scientists are looking at hydrothermal vents as a possible way to extract certain minerals that are found at hydrothermal vents. It's not being done at this point in time, but it's being explored. All right, here's a law to know called SMRCRA, which is the Surface Mining Control and Reclamation Act. And this requires companies to post a bond and restore the land when they're finished mining. So that's a law to know. We just call it SMRCRA for short in APES. All right, so these are ways that you can make a difference with some of the ecological and environmental impacts of mining. And this is an interesting article about using bacteria to clean up some of the problems from mining. It's called bioremediation. And so they've been using it with acid mine drainage. And so it's sulfur digesting bacteria are used. And it's a type of bioremediation. And bioremediation is using a living organism, usually bacteria, to clean up some sort of waste product. Also here, they're trying to fix acid mine drainage by adding an alkaline substance, whether it's limestone or sodium hydroxide, in order to raise the pH and make it close to neutral, which is what it should be. Alright, so next law to know on page 658. The General Mining Act of 1872 allows mining on public lands for very cheap. This law has not been rescinded, which means that it's actually still technically on the books, and the people who staked a claim with the General Mining Law of 1872, those claims for mining have been passed down in wills. So people have inherited the claim for certain lands. And so if you have this claim for land that your ancestor got way back in 1872, this law says you do not have to reclaim the land when you're done. And so it's a pretty bad law. So basically anybody can go and mine the area and not have to clean it up or make the land look nice again when they're done. And any new claims that are out there, there has to be reclamation. But these old claims, no reclamation is part of that law. It was also gave away land for the cheap. And some of that land is near national parks. Now, not all that land is going to be mined because you have to be economically feasible. Just because you own a piece of land and there's minerals in there, sometimes the cost of digging it out, paying people the diesel fuel for your tractors and wash plants, sometimes that costs more than what you dig out and sell. So just because these claims are out there does not mean that people are going to mine them and make any money on them. Going on to page 660. Recycling metals uses vastly smaller amounts of energy than exists in extracting and smelting from ore. Pay attention to aluminum as well, because aluminum, the energy required to extract aluminum actually is a metal that doesn't just come naturally out of an ore. It actually comes from filtering the Earth's crust and extracting the aluminum, not necessarily filtering, it's actually a chemical process. So basically you take dirt and you do a chemical process and extract the aluminum out of the dirt. In the process of doing that, it uses huge amounts of electricity to do that. And so recycling aluminum actually uses something like 99% less energy for recycling of that aluminum. And so recycling is huge for saving electricity and preserving and unrenewable resources. So that's a good thing. And that is all the sticky notes that we have on chapter 23.